And yes, we are live now.
So it started with a thank you for watching page. Apologize, we are not done yet. We are just starting. Uh,
All right. So, hey, friends. So, this is me, Vishwas Nan. I'm the host and actually the co host of the series. I don't know what's my position here. It's just that we are learning and we are brainstorming some ideas. We are learning data engineering. And of course, the experience that Akash sir has been carrying over a course of time. And this is the part two of the series where we are actually taking a view about how team works at scale, how team evolves at scale, and also how is the challenging part of data science or data engineering taken care. And of course, we'll obviously have a lot of series on Kubernetes. We are having a lot of series on a lot of things that we
Software
have talked.
architecture.
Yeah, of course, the software architecture
That's
is
what you
coming
forgot.
for sure, and that's actually something that we are looking forward to. And of course, over to you, Akash sir. So a quick round of intro, and let's get it started.
Yes. So in case we haven't talked before, I'm Akash Verma. I'm a senior solution architect. Uh, I'll want to start with my host Vishwas. He's been interviewing me, and we're talking about data engineering. So, in case you're new, please go and subscribe to Vishwas on his YouTube channel or see it on LinkedIn. If you don't know me, well, you will get to know me today. And I talk a lot about technology on Cafe IO, which is where I spend my where I post videos, and I also have a blog which is called cafeio.xyz. This is where I talk about my experiments, experiences, failures, mistakes, learnings, all of that on technology and predominantly software architecture. I am by designation an architect, and I've been building systems for quite some time, been into AI systems for some time, but I've also have good exposure to doing mobile applications, web applications, and data-driven systems. So yeah, let's get this started, Vishwas. So back to you, and let's do a quick recap of where we left, and then we
Yeah,
might want to come back. So should I share your
screen. Yeah,
drawings? Yeah.
yeah. Please go ahead. So yes, so last time we talked about the what do you call it? The data engineering roadmap or is the data engineering pathway because we identified that trend to select the databases, trend to analyze data, and experimenting with a low code and a no code and an event driven system is what we are trying to build. And over a course of time, if you just see how data engineering is evolving, probably there is an outdated version of batch processing that people have worked upon or things like that, but there's obviously a new way and a new trend. Like we didn't just stop there. We just didn't stop about just giving you some sort of an insight about what is it all about. We took an example of cricket. We wanted to have an comprehensive understanding about how event driven systems are, how an event driven data flow is happening in a system, and we need to perform an event driven matrices. And everything at the end of the day just landed on to FinOps as something as a new engineering practice that we obviously go behind, because anytime that you talk about today, FinOps is the most fascinating topic because everybody wants a bigger stake in a system, and everybody wants to understand, summarize the system over a course of time. And then we went to the Apache Spark, where the question was asked in terms of what's the most challenging part when it comes to a batch processing. And batch to event driven is one of the key point that we obviously discussed there. And of course, graph is something that is way too hot in the industry out there. And Spark tuning is much more important than just going out there and building something on Spark. And that is where Apache Spark came into the picture. And learning Spark would be great for the modern world, yes, but if you have a perfect skill set, it's just Spark tuning plus some snowflakes. I'm still learning Spark tuning because I don't know where are the resources. I'm still yet to figure out. And of course, this series is going to have a lot of insights about how Spark tuning can be built in and everything related to that. And of course, Snowflakes was one of the addition that he obviously talked about when it comes to a database or else a place where you can store all the data, manipulate it, and things like that. But whenever we talked about an instance, storage is getting cheaper and compute is costly. At the end of the day, you can store as much as data as you want, but to compute on the same data, it's going to be tougher and tougher. And data is the new billing, right? The moment it goes and sits as 1 GB, 1 GB is not 1 GB the next month. 1 GB is going to be 2 GB or 2.5 GB. And that means 1 GB plus 1.5 GB. And that means you are paying not a constant amount every single month. You're just having a variable scale that is happening. And of course, cloud is required. Cloud is absolutely an hot piece of topic that we have because customer churn, of course, if you think anything as a platform which is cloud hosted and cloud supported, at the end of the day, it's a customer churn. Cloud data platform is costly. Product plus data platform work on FinOps. That is how we are brainstorming the ideas. Like we are going behind, putting in the customer churn, talking about cloud data platforms, which is costly. And now we think based on a product and a data platform perspective. And this is not just product, which is just a product, it's a data product perspective that we're talking. And of course, different specializations comes into the picture, not just one. There's a lot of specialization, and of course, there are different aspects to the cleanliness of the data. Where the previous key in data is being lost, the data points have been uh, misused or misunderstood over a course of time because every time it's not the same data that you deal with. And of course, we then move to how data contracts is going to make an impact in all the problem statement that you saw above. It can be a domain driven, it can be a logical system where there's one domain and there's one leader, and he can be a platform leader and he can be considering so many things. This is specifically an hub and spoke model that we are talking about. And now, how can do not forget that you are even considering the small data. So that's why there is an USB drive here. So that's where I put in. But this is how a typical data contract associated system looks like. So there is obviously a communicate engine that is obviously. So we talked about PubSub, but we'll obviously go ahead and we'll talk about how this can be pursued in productions. And of course, storage is getting hot and cold. Of course, it can be pursued in any different fashion. Years of evolution of service, data contracts, and there's one storage out there, which that storage is giving out an perspective of analytics and modeling with all the downstream services communicating together. So I think that's the whole summary of whatever we had because that was just a pathway discussion. But today we are going to go more into the production. That means what happens if a system exactly similar to Amazon or Google thinks data contracts and thinks even streaming at the scale or when they want to move from batch to stream processing. Today is the hot topic of discussion out there. So what do you, Akash? So whatever is your thoughts about whatever we discussed last time, you can just go ahead and talk
Cool.
about
So
this.
sure. So let's build on this, right? Let's try to go back and see what data contracts were, and then try to go and move forward from there. So I think teams rely a lot on systems and services, and these services are internal. There's usually a concept of a service contract, and when people who have been developing web services for quite some time, they would know there used to be a SOAP contract, and the contract used to be uh, a discussion point. Very similarly, you have API blueprints, which are the sort of discussion points when you are talking of services. So data contracts are, like the name says, they contracts for data. Now, what and where they come in is basically the producers and the consumers get to have a conversation around data. Now, this might not be a service interface, but they might want to talk about the schema that they are trying to get, the keys that they want to get. There should be some sort of a relationship that they want to build across, let's say, data elements and all that. And all of this basically can be factored in within the data contract, which ensures the maximum readability happens, and in case there's a change, that change management process is built. So it's basically just a few lines or a skeletal of how the data should look like, how the DB object should look like, what, as I mentioned, what are the keys that should look like, and that's pretty much what data contract is. Now, there could be also conversations around other areas. For example, how frequently are you trying to ingest the data? What is the type of ingestion? Who owns the data, whether there is an individual owner of the data or there's a team owning the data, what type of data is being extracted, the levels of access that we want to talk. You might want to go table level, you might want to go to row level, schema level, etc., etc. There should be governance conversation around it. And if there is there's a couple of other systems that are impacted, we could be talking about that. So by far and large, data contract is an enabler. It is an enabler for the conversation that two teams need to have around the data. That's what effectively is a data contract. Now, is it a perfect world with it? No. Are there trade-offs? Are there challenges? Yes, absolutely, and we'll talk about it. So yeah, that's how I think of data contract. Initially, I'll say to begin the conversation. You were able to capture that? Are on mute.
So most of the times when I think about change management, it's not just schema. We also talk about database transition. That means if something is there on Redshift, can we go beyond Redshift is something that we always talk about, right? Is there any cheaper version of it? Is there something as good as Cosmos DB that we can put in, or else DynamoDB is something that we want to transition towards, and we are putting in more of the serverless aspect. So, how is that entire change management considered in the picture? So, let's just talk about change management as one of the
So
topics itself.
So change management could be really, really critical when you have systems which are exchanging data. Uh, Usually, people have change management processes implemented when there is a movement into production, when there's a service management. But most of the times, data interactions are expected to just work, and very it does not happen that frequently, but a lot of times when these things break, most people would have no idea where to go. So the change management around this, I don't think exists very strongly, or at least I have not seen that existing very strongly. So that's the first thing which I'll want to say. But at the same time, what data contract help you to do is they help you enable the conversation for change management. If you have a data contract, you can hand it over to your support team. In case your pipelines fail, they can very quickly match and see, was there a data quality mismatch with the upstream, or somebody screwed up a date or something like that. So there could be data quality challenges which could lead to failures in the pipelines, and our contract would help enable and facilitate a change management conversation.
Is automation the biggest curse here? Because a lot of challenge that we talk about is always about automating it the right way and also automating it for a longer term. So, is automation going to build a challenge of what can't be designed for a system, or else is it going to be kind of a vendor lock-in when there is something called as data contracts coming, or else
I
is
think
it
you're
going to
talking a
enable
couple
us?
of different things. Automation can exist definitely, and
Yeah.
automations can be built. Am I aware of any specific example at this moment? No, of those automations, but I would believe that most pipeline systems would have the ability to bounce off certain alerts given a certain condition is not met. And in this case, the condition not being met would be uh, non-adherence to the data contract. So I think automation can be done. Vendor locking is a very different conversation altogether. I don't think that if there's a specific vendor that you have in mind, which enables this. I'm not sure if that's what you're asking.
No, no, I'm asking in terms of when we start interacting, let's say anything as good as um, a system that can be used. Like let's say there was obviously a lock-in where they don't want to move away from a system, or else there is obviously an software infrastructure that is built around that database, and now they don't want to move apart from it. So the kind of a challenge that we face when it comes to database migration or
Okay,
anything with
got it.
respect to that.
So,
So that
okay,
is what
so
I
I'll
asked.
say I always say this to the teams I work with. Migrating databases is the hardest piece of migration ever. It's not just about the database; it's actually about the whole ecosystem that gets challenged. So
Hmm.
first, you have to worry about the database product itself, the migration of data. Then you have to, and I've seen enough systems to say with confidence that there are places where people don't know how many consumers are there on the database. They just don't know. So if you want to migrate a database, uh, you first have to find who's consuming it. It's a very difficult problem for large enterprises with large data warehouses that were built, and the problem I think would have magnified in the case of a data lake. I think if you want to move a data lake technology from A to B, I don't even know how humongous that could be, a multi-year project in itself. So what I was saying is, it's not just about the database product, it's largely about the consumers. Most vendors to whom you are migrating to would give you the ability to do some kind of transfer of data migration movement. They'll enable you, format conversion. They might even give you some, code conversion tools to, convert your procedure from technology A to technology B. What they cannot give you is, the ability to find out what's downstream systems are consuming, your database. And that's just an exercise which has to be done manually. You got to send mails to, well, every delivery lead in the organization and say, hey, I want to move this database from A to B. Are you guys using it? And they'll say yes or no or whatever. So yeah, it's a very difficult conversation to have. And but I think in the concept of data contracts could definitely help in bridging some of these, because it's very natural when you have a single piece of document or multi-page document which describes all the facets of the data management. You could make your life a lot easier when you are talking of consumption.
I
All
think we
right.
talked a lot about a data contract making an impact. So now let's go ahead and talk about the evolution of data meshes. I think by now I think I'll have to open one of my posts that I did, and I think that would obviously give a lot and lot of insights here. I think
Sure.
I'll start sharing this post.
Is it
So
going to
this
be
is
kind
one
of
of the talks that I did for
vendor
Neo4j.
lock-in
I
when
think
there
it
is
was
something
collaboration with Docker. Yes.
called as data
Yes,
contracts
it was
coming
in
in?
collaboration with
Or else,
Docker and
I
is
Neo4j.
it
think you're
going to
talking a couple
enable?
of
And
different
of
things.
course, the ownership is something that we talk about. There is a
Automation
data
can
platform and
exist
a lot of things
definitely,
coming up.
and
Yeah. So when I
automations
think of
can
a
be
data
built.
mesh, this is what comes to me.
Am I aware
This is
of
how I start seeing anything as a data mesh. So there is
any
obviously
specific
different
example
source
at
of
this
data that is
moment?
getting
No,
stored,
of those
and of
automations, but
course, there is different set of data sets that we talk about. It's not just one data set coming into the picture, it's multiple amount of interaction that goes
it's
behind when
given.
we talk about in a data set.
Vishwas, your screen share has some YouTube or some video playing. I think it's coming from your screen.
It's my screen.
Some tab is open which is playing some data contract. So I think automation can be
I
done.
don't think so. I don't have any tab which is open, but now
In the background, can you see if you have YouTube open?
I
YouTube,
don't.
LinkedIn, maybe.
Uh, Is it the same voice that we are talking?
Yeah.
Okay, okay, okay. I can understand that. Why? I can share you now this one. Okay,
No,
I
no,
think
I'm
we
ask.
had I had opened that, and now it will be gone. Now
Yes,
it
it
will be
is
gone.
gone. Yeah.
Yeah, it's gone now. It's gone now. So there is obviously virtual data warehouses and things like that. But still, we talk data mesh is the new way of thinking about anything data. So data warehouse, data lake use cases. How are they giving rise to the data mesh architecture that we are talking today?
So, so warehouse and lake, let's start with them, right? They are two different approaches to managing data in an organization. A warehouse is essentially a centralized uh, conversation, and on the other hand, a lake is kind of more flexible and uh, typically seen as a more scalable approach. And people would dump data, without having a structure. So, uh, a warehouse will have a schema. A lake would be schemaless. All those conversations. Uh, I think we are moving towards a hybrid, and data mesh is a more recent concept. I have not actually worked on an implementation of a mesh, and but what I know is that it aims to address some of the challenges that arise with traditional data management approaches. So it tries to attack data silos and slower time to market for data products, and it basically builds a more decentralized approach to managing data, and where each team or domain, it could be a domain driven or a team driven in an organization, is responsible for each data product, and data is treated as a product that needs to be having certain attributes like discoverability, interoperability, reusability across the teams and domain.
Hmm.
Now that's what a mesh is. If you think about it, I believe it's a very natural evolution of a warehouse and a uh, lake, kind of moving towards a hybrid, where you have a hub and spoke model, where you have a platform powering a lot of different domain driven databases, like we talked the last time. So I think mesh is a very natural evolution to I think the data lake and the data warehouse conversations. But I think people are realizing that there is a need to have both centralized and decentralized, and hence I think they are targeting data meshes.
Sure. So now we have a lot coming up, right? There is obviously a new conversation in the market, which obviously comes up, right? You know, like I can just take an example of how Audi uses Kafka in order to stream data to back to their system, and
Wow,
yeah,
Audi.
like this is one of the use cases which Confluent gave out, and I was pretty shocked when Audi uses Kafka in order to stream back data inside into their system, and they literally started. Actually, they were one of the biggest clusters. I think Neuralink became one of the biggest clusters afterwards because their streaming system is fantastic when it comes to the observability space, and there are even talks going on where they really want to cut down the cloud costs. So now they are moving towards Graviton system, though they have such high stream of data coming up. I don't know whether the microservices will survive or not. But once you think about building the team that is ready for production, and there's a lot of data coming at that stream, and the scale of what we call as a stream data set is something which is huge. So how can teams now evolve in order to build something that is a go-to market and a go-to production level of engineering when there is such huge streams of data coming out into the system? Like we can just talk around this entire data system that we have, or else I can take out
Got
some
it.
image that we
So
had.
let me think through this. So I think one of the core trends which is emerging when it comes to data is uh, the consumption patterns are changing. If you think about it, or at least when I started my career, I'll try to give you roles. There used to be a DB admin, there used to be an analyst, there used to be a BI person, there used to be a developer, and there used to be an ETL developer.
Hmm.
right? So there's 4 or 5 roles that used to exist. Now I think people are expecting a lot of databases. Everybody wants to, nobody wants to spend time into admin. They just want technology that scales well automatically, or at least they don't want to know how it does behind the scenes. Maybe they don't want to put money into hiring people like database admins and all that, which may or may not be a good idea, right? So where the world is moving towards, what I'm trying to say is doing a lot of self-service. A lot of different people and teams want to do self access to data, and build tooling around it which makes accessibility of the data easier. With the whole notion of data mesh, I think that though, and modern cloud data products, like I've used Snowflake. It's really intuitive to use Snowflake. They keep improving their consumption ecosystem. They are great for analysts. They have built-in charting capabilities. They are bringing Python into the ecosystem to get the developers. So there's a lot of tooling around. If you see for RDS, great integration with AWS QuickSight. You can do so much of drag and drop and quick fire analytics using AWS QuickSight into, if your data is in RDS. QuickSight can do with other databases as well. But what I'm trying to say is a lot of self-service is coming up, and that can only be enabled if the data is stored in such a way where there is a meaning to it already. And that meaning can arise from having the nice conversations like that we talked about data contracts before, and having performance tuning conversations, having nice indexes and blah blah blah. So I think that's where a lot of teams are moving towards, when to accelerate towards a more self-service model, and that's where I think your question of productionization could come in.
Sure. I think let's end the part two, and I think there's no part three because we have covered a lot. We are not
Yeah,
done
I think I was
editing.
about, we have covered quite a few trends, and we are almost like 27, 28 minutes into the session.
Yeah. So now let's talk about the challenges. I think you have to share my screen now, and now let's talk about the challenges because you told about QuickSight. QuickSight happens to be a service which is managed by Amazon, and Amazon does not fail to set the benchmarks. Like I have seen the moment they gave out SageMaker, the next AWS reinvent, there was SageMaker Canvas, and I was like, this is a low code and a no code version of it that we have right now. And QuickSight is managed by Amazon, but now when it comes to people going behind HIPAA compliance, or else people going behind such sensitive data, just like banking, or else as good as it can be as good as not just banking, it can be as good as a Fitbit data coming out there and streaming into my system right now. So, what are the challenges in production that we have right now, and what are the tools or the technology that we need to rely on when we talk self managed and we want to scale as quick as possible?
I think, can you repeat your last part of the question? I
Like,
think there's two things in there.
I think I asked about data compliance is something that we always go behind, right? Like there is HIPAA compliance for healthcare devices, which is much more sensitive in terms of data. But let's say in terms of the banking system, which is not that critical, but it's critical for a system. And it can also be as critical as streaming in a Fitbit data into my system. So there's a lot of trend that goes behind strategizing what to be adopted, what not to be adopted. So that was my question.
So you mean how to pick a technology? Is that what you're trying to ask?
How to pick and what are the challenges that we might face?
Okay. So when you pick a technology, I think it's a very broad question. You kind of need to be aware of the problem space that you're trying to solve. There, and I'm talking very generically. There isn't this doesn't this applies to everything, not just databases. So you need to be very clear on the problem space you're trying to do, uh, and by problem space you have to narrow it down to the specific challenge. For example, if I am trying to find a database product, I would not, I have to go and be much more specific about it. I cannot just have a database product. I need to have a database product which can support, let's say, columnar data, which can scale to terabyte GB, etc., etc. So I need to have those, some of those non-functional attributes in terms of the product itself beforehand, before I go out in the market. Because once you go out in the market looking for tools, you'll find plenty, and each of them will have, oh wow, I wanted this, hey, I could use this. Sometimes you'll find solutions you didn't know you wanted. It might sound cool, but that's not in your problem space. So define the problem statement well, then go out for doing a vendor assessment. Have a predetermined set of criterias, for doing that assessment, so that you don't get everything, try to get everything under the hood. uh, and I think that's the one matrix which you should follow through. And then follow and read through some articles. Like, for example, I frequently used to go to Magic Quadrants, not anymore, for product recommendations, because their evaluation methods are quite good. I don't go to Gartner's Magic Quadrants for products always, though I do that some from time to time. But I go to them for the evaluation method and the parameters that they use. They are very, very exhaustive and thorough. So yeah, that's what I'll say about picking a technology. Challenges are, again, the first one I'll say, most people don't know what is the problem that they are trying to solve. You do not have a problem of having a database. That's never the case. You don't ever have a problem of selecting the right programming language. That's never the case. If it is about selecting a programming language, then you need to know what type of programming you want to do. If you want to do embedded device drivers, you don't want to select Python for it. Great language, right? Python, and vice versa. If you want to do data science, you wouldn't want to go use Rust programming for it. I don't know. Rust is a great language, but again, the ecosystem isn't tuned for uh, basically doing data science. So I would say knowing about the problem is half the battle. The rest half is working through the options and eliminating for them. Do Yeah, that's what I'll say.
Sure. I think I have a lot to actually rethink when I have to put an image, because this is a very deep conversation in a very short span of time. It's not like we talked about an instance and we had something to say there. I think it's a huge conversation. I think I have to redraw so many things. I have to relook at this stream again. And I think that is the whole point about this conversation, where we don't just share about just data contracts or some of the aspects here. We just have a lot of questions that is popping up. I think this is the end of the part two, folks. There's a lot that we have to discuss. There's a lot that we have to cover out. And there's a lot that I have to learn, because there is a whole new conversation about data mesh which
The
is coming
journey
up,
keeps flowing through. Don't
happening.
worry too
Yeah.
much about it.
That's true, and we'll be coming back with another show soon, so stay tuned for that. And the image will be given out in the drive link in this video description as well as it will be there on our LinkedIn post as well. So do check that out. And thank you so much, Akash sir, for being on the show. It was a nice show that we had, and it was a lot of insight that came up in. I think I learned one more
Thank
new
you.
tool from Amazon, QuickSight. I had never
Okay.
never worked on QuickSight.
Thank you, Vishwas, for the conversation. Hey, guys, thank you for tuning in. If you have listened to this, if you have not, and if you're seeing the recording, do watch the whole video. Feel free to bump up on us, ping us, poke us on LinkedIn, drop in a comment on YouTube. I My YouTube handle is Cafe.io. Vishwas is Vishwas. And thank you and have a good night. Bye bye.
Thank you so much, folks.